Okay, the third type of transformation, that is rotation. That is rotation. So we'll remind each other again that in transformations we have a shape, we have a transformation, and the transformation maps the shape onto an image. All right. So how do you describe a rotation, right? Let's say you're looking at a shape. You see that the shape has been rotated, right? The shape is spinning about a fixed point. It's spinning around a fixed point. What are the things that you need to mention in your description? Well, first of all, you need to mention that it is a rotation, right? Whenever you identify a rotation, you need to mention that it is a rotation, right? The first thing is to mention which one of the 6 transformations you are looking at. The next thing is to talk about the angle of rotation. Now, for our studies, there's only 3 angles of rotation that we'll need to think of: 90 degrees, 180 degrees, and 270 degrees. Okay, so those are the only 3 angles, right? So if it flips through 90, 180, 270, and then it's back to its original position, right? The next thing is the direction of the rotation, right? The direction could be clockwise or anti-clockwise, right? So how was it flipping? Was it flipping clockwise or was it rotating anti-clockwise, right? Last thing is the center of rotation. This is the point around which the object is rotating. The object must be rotating around a particular point, right? It could be any point. It could be the origin, right? The point 0, 0, right? Where the x and y axis cut each other, right? This is the y axis, that's the x axis. Where the x and y axis cut each other, an object can be rotating around that point, or it could be any other point on the Cartesian plane. It could be a corner of the shape, right? If I have a shape like this, if this is the center of rotation, the shape can flip and stay stuck to that corner there like that, right? So it could be a corner, or it could be a part of the one of the sides, etc. So there are many centers of rotation. What we want to do is to first of all look at the origin being the center of rotation, right? What happens when the origin is the center of rotation, right? If this object here rotates 90 degrees, right, it's going to flip almost like once, right? So the result is going to look like this. We just have a different color there so that we make it clear. So it looks like that. So if it flips once, 90 degrees, about the origin, right? This is the center there. And it flips once, that's a 90-degree rotation, right? If it flips again, this becomes a 180-degree rotation, right? So now our shape is here, right? Our shape is like this. Then we have our green here. So that's 180. From here to there, that's 180. If our shape flips 3 times, 1, 2, and comes this side here, this is now 270-degree rotation, right? So that's going to be something like this. That's a 270 degree rotation, right? So this is when they are rotating clockwise, right? Clockwise. This 270-degree rotation is equivalent to a 90-degree anti-clockwise, right? So this shape could have ended here if it just went 90 degrees anti-clockwise. So whether it goes 270 degrees clockwise or 90 degrees anti-clockwise is the same thing, right? So that's something to note there. Now, for rotation, we have matrices for rotation about the origin. Remember, these matrices only apply when the center of rotation is the origin, right? The point is 0, 0, where the x and y axis meet. If a shape is rotating around the origin, then these matrices apply. If we have any other center of rotation, these matrices are null and void. They do not apply whatsoever. They only apply when the matrix, when the shape is rotating around the origin. So now, for a 90-degree clockwise rotation about the origin, this is the matrix we have: 0, minus 1, 1, 0. So that's the matrix for a 90-degree clockwise rotation about the origin. For a 180-degree rotation, the matrix we have is minus 1, 0, 0, minus 1. So this is 180-degree rotation. Now, if you notice here, I did not bother saying clockwise. Why? Because if you go 180 degrees clockwise or 180 degrees anti-clockwise, you end up in the same position, right? If you turn and face backwards, whether you turn going right or turn going left, if you're turning to face directly backwards, you just end up in the same position. So it doesn't matter whether it's clockwise or anti-clockwise. So 180-degree rotation, no need to write clockwise. You won't be penalized though if you write clockwise. It's okay. So the matrix is minus 1, 0, 0, minus 1. For the 270-degree clockwise rotation about the origin, it's 0, 1, minus 1, 0. So it's your business to memorize these three matrices, right? These three matrices work in the same way as the matrices of reflection do, right? If you want to find the vertices of your image, you take the vertices of the original shape and you multiply by the matrix which applies. Now again, let me remind you, this applies when the origin is center of rotation. If you're asked to perform a rotation where there's another center that's not the origin, these matrices do not apply. Here's an example. A quadrilateral P has the vertices 1, 1, 3, 2, 2, 3, and 4, 4. Draw the quadrilateral P. So we're going to draw this 1, 1, 3, 2, 2, 3, and 4, 4. So 1, 1. The next point is 3, 2, 3, 2. The next one is 2, 3, 2, 3. And then the last one is 4, 4. So we have 4, 4. So this is our funny looking quadrilateral there. Okay, that's our quadrilateral. I have a name. It's quadrilateral P. You can label it P there. Now, P is mapped onto triangle. T. It's not a triangle. It's a quadrilateral, right? P is mapped onto a quadrilateral P is mapped onto a quadrilateral T by a 180-degree rotation about the origin. So draw quadrilateral T. What do? We can make use of our matrix, right? We take these original points, multiply them by that matrix to get the new points, right? So we have to write them as columns. Whenever we're doing these multiplication operations, we have to write them as columns. So we're going to have minus 1, 0, minus 1, multiply those points. So let me list my points. 1, 1, 1, 1. Well, let me put a bit more space there. So I have the point 1, 1. And then the next point is 3, 2. 3, 2. And then the next point is 2, 3. 2, 3. And then the last point is 4, 4. 4, 4. All of them are going to be multiplied by that matrix minus 1, 0, 0, minus 1. This is for 180-degree rotation. Minus 1, 0, 0, minus 1. Minus 1, 0, 0, minus 1. Minus 1, 0, 0, minus 1. So if I multiply these, I'll get minus 1, minus 1, minus 3, minus 2, minus 2, minus 3, minus 4, minus 4. So that's what I get, right, when I multiply these. Again, if you're struggling with multiplication of matrices, just feel free to visit the video series on matrices. So now let me just collect these points in a corner somewhere where I can write them and make space for my image. So let me bring these guys up. Minus 2, minus 3. And then this one is what? Minus 4, minus 4. I'm just bringing them up to make space for my image. So now I can plot those points, right? The first one is minus 1, minus 1. Minus 1, minus 1 is that point. And then the next one, minus 3, minus 2. Minus 3, minus 2 is that point. And then the next one is minus 2, minus 3. Minus 2, minus 3 is that point. And minus 4 is that point. So use a different color there, maybe green. And then here we go. There's our image. And what's the name of our image? Our image is T. So there is our image. So we successfully rotated this triangle P 180 degrees about the origin, right? And we use the matrix to rotate that shape there.